Hello everybody. So let's continue our dive into factoring trinomials. So last time we went over how to manage factoring simple trinomials where the first coefficient, the number out front of the x squared, is not there. Or if it is there, you can think of it as just being a 1. There's no number out front of the x squared term. And then we ended on last class one that did have a number out front. Okay, and so those get much more difficult, and we did this example in class. And the only thing I presented last time was that we could guess and check this. So here's the example from last time, exactly how we did it. Copy and paste it from the last lesson. Notice that it has a number out front. It has a 2 in front of the x squared. So if I'm going to factor this, it's going to factor into two binomials, and the first two terms have to multiply to give me this 2x squared. So they're both going to have an x and an x to make x squared, and they have to be two numbers that multiply to 2. The last terms are going to have to multiply to give me this last term of positive 15. So these are going to have to be something like 1 and 15, or 3 and 5. Or 15 and 1 and 5 and 3. Okay? So we just guessed and checked this, since thankfully there's not many things that multiply to 2 besides 1 and 2, or 2 and 1. And there's not many things that multiply to 15. There were only a few possibilities. And so these were all of them. Every combination of them. There were just 4. So guessing and checking was simple. And if you want to read this in detail, it's what we did last class. So if you guess and check all of these by multiplying them back out, you see that this one right here gave us back the original problem. So this was the answer. Now that's nice. We can find an answer. You can find it and work very hard and think through all the possibilities of things that will multiply to give you a 2 and all the things that would multiply to give you a 15. But if these numbers have more factors that could multiply to them, this is going to get really messy, and you're going to end up with a lot of things to guess and check. So it would be really nice if there was some systematic method to do this, and there are a few that exist. I'm going to show you one called the AC method. Okay, another one is similar to this, but it uses a few tricks that are basically we need more math to explain how they work, and I don't want to show you something if I can't explain how it works in a short video. That would take a much longer video. But the other method seems kind of magical too, so it's kind of cool. So if you want to look into factoring methods, you can Google those. But the AC method is one that's really systematic and straightforward. It just takes several steps to get through. Okay, so let's actually do the same example. Since we already know the answer is x plus 3, 2x plus 5, let's see if we can factor this with this AC method. Okay, so this is the same problem. Here's how the AC method works. These three numbers, when you have this thing in this trinomial in descending order, these three coefficients, these three numbers, are known as A, B, and C. Okay? The AC method is, we're going to start by taking A and C and multiplying them. Okay? So here, A equals 2 and C equals 15. We're going to multiply them together, and that would give us 30. Okay? Now what we're going to do is what we used to do for the easy problems. Remember, for the easy problems when there wasn't a number out front, we would just say what numbers multiply to C and add to B. We're going to play the same game, except for we're going to see what numbers multiply to 30 and add to 11. And so that's all that writing is saying. So let's see. These are all the numbers that multiply to 30. Because there's a limited number of things that multiply to 30 and an infinite number of things that add to 11, let's list all the things that multiply to 30 over here. So 1 times 30, 2 times 15, 3 times 10, 5 times 6. As far as integers go, that's it. Unless we're doing two negatives, but we don't need to worry about that. And so what do they add to? 1 plus 30 is 31. 2 plus 15 is 17. 3 plus 10 is 13. 5 plus 6 is 11. And there we go. We found the winner. 5 and 6. So the AC method starts by just taking the A times the C and getting a number. Finding multiples or factors that multiply to 30, or that AC number. and seeing which one adds to the middle term number to 11. Okay, so that gives us our two special numbers right here, 5 and 6. So this is where the AC method starts to get different from our traditional factoring. Okay, what we're going to do now is, ignore all that, we're going to split the middle term, okay, using these two numbers that we found, so 5 and 6. So here's what I mean. So this is our original problem. We found 5 and 6 are the two numbers we want. The middle term is 11, or technically 11x. If I were to break it into two pieces, would you agree that 5x plus 6x does equal 11x? So what I have done is rewritten the problem in an equivalent or equal value, or equivalent equal expression here, but I have split the middle term into two separate terms, 5x and 6x. Okay? And remember where we got our 5x and 6x from doing this AC thing, where we multiplied a times c and got 30. Found all the factors of that and saw which factors added to the middle term. Okay, so here we sit with our new problem. What we're going to do now is called factor by grouping. Okay, and so it's quite simple. Notice that these are all additions through here. So I'm allowed to add grouping symbols because of the associative property wherever I want to. So what we're going to do is lazily group the first two numbers and lazily group the last two numbers. Okay? So this is just what we have. Original problem, split the middle term, and then group the first two and last two terms. So all I did, whoops, come back here. All I did was add grouping symbols. Okay? Now, some of you may ask, does it matter which order I put the 5x and the 6x in when I split it? And the answer is no. You'll get the same answer in the end. Your second and third and fourth steps may look slightly different, but your last step will be the same. Okay? Now, what we're going to do to factor by group is we need to look at each of these groups now, and we're going to do something very simple. In the first group, we're going to look for a greatest common factor between these two terms to factor out of this group. And then we're going to look in the second group and do the same. Find a common factor, or the greatest common factor, to pull out from these two terms and factor it out front. That's the simplest, most original form of factoring polynomials that we should understand or should have covered. So let's do that. So out of the first group is 2x squared plus 5x. The only thing these two terms have in common, 2 and 5 have no common factors, but x squared and x, I can factor an x out of each term. Both terms have an x to give away. So if I pull an x out, 2x squared, if I take one of those x's, just leaves me with 2x. And 5x, if I take its x away, just leaves me with 5. So I pulled an x away from both of these. That's the only common factor that these two had. For the second group, 6x plus 15, they both don't have x's, so I can't do that again. But 6 and 15 are both divisible by 3. So I could pull a 3 away from both. So 6 is 2 times 3. So if I pull a 3 away, I'll be left with a 2x in this first term. 15 is 3 times 5. So if I pull a 3 away, I'll be left with 5 in this first term. And so this is what I get. Pulling the 3 out, I get 2x plus 5. Or factoring the 3 out, I get 2x plus 5. Okay, so this is kind of what our problem looks like. Original problem, split the middle term, group them, and then I pull the greatest common factor out of the first group and out of the second group. Okay, see how this is rolling along, and technically I should have equal signs going from one line to the next because these things are all equal. Okay, so here we sit. Now I want you to notice something. Okay, look at the first half of the problem, and I hope that you notice that there's something identical in the first half that is identical in the second half. You see that the first and the second parts, the front and the back of this problem, both have 2x plus 5 sitting there. Okay? That will be one of our factors when you factor by grouping. So 2x plus 5 is one of our factors. Well, if I take 2x plus 5 away, if I could cover all this up, what are you left with? X plus 3. That will be our other factor. Okay? So when you're sitting here, You notice they have an identical part. They both have 2x plus 5. If you sneak that away, you will be left with x plus 3. Those make up the two factors that we will that make up our answer. 2x plus 5 and x plus 3. And if you go back and check, we got the same factors. I think we wrote them in a different order, x plus 3 and 2x plus 5, but that is the same answer for when we factored this problem originally. Now, I went really slowly and talked through each step pretty meticulously, so it feels like this may take longer than just guess and check. But believe me, whenever you start getting things with a lot of possible factors, this will save you time and at least give you a systematic way of factoring trinomials that have a leading coefficient. Okay, let's try another example, and let's throw a negative in this one. Okay, so here we go. Another example, 6x squared minus 7x minus 20. So we'll go through the steps more quickly or fluidly this time. First things first, there is a coefficient out front, so there's no easy way of doing this. Let's use our AC method. A times C, so 6 times, now whenever there's minus signs involved, let's go ahead and attach those to the number. So think of this as more like negative 20 or plus negative 20. So 6 times negative 20 is negative 120. So the AC method tells me I'm looking for two numbers that multiply to 100 and negative 20 and add to negative 7, that middle term. So there's a lot of numbers that multiply to negative 20. If you tried to guess and check this one, you would have so many polynomials to multiply. It would be huge. So here are all the sets of numbers that multiply to negative 120, and then we add them up to see what they add to. And I'm looking for negative 7. And we see right here this set of numbers, 8 and negative 15 is what gives me negative 7. So as far as my AC steps go, multiply A times C, that tells me what numbers I'm looking for, multiply to that, and add to negative 7. Now I have these two numbers, 8 and negative 15. I will split negative 7 into 8 and negative 15. Special note, the order does not matter, okay? I can put 8 and negative 15, or I can put negative 15 or 8. I will suggest, if you have one negative and one positive, to put the negative first. It makes the grouping easier because you don't have to worry about this sign being attached to the 8 or not, because the negative is grouped inside the parentheses, and there's just less chance for losing that negative. So I split 7x into these two numbers, negative 15x and 8x. Ask yourself, are these two expressions equivalent? Yes, because negative 15x plus 8x is negative 7x. So these two expressions are equivalent. Group them, so just add your parentheses around the beginning and the end. Now let's see, is there any common factors from 6x squared and a 15x? Well, I know 6 and 15 are both divisible by 3, so I'll pull a 3 out. X squared and x, both terms have an x for me to factor out as well, so I will factor a 3x out of both of these terms. When I do that, if I 3 times what gives you 6? 3 times 2, so a 2 will be left, and I have x squareds. I'm taking one of these x's, so 2x minus, I'm taking the x, but 3 out of 15, let's see, 15, what, 3 times what? 5, so I'll be left with a 5 here, okay? See if I can just show you that part. So I'll pull a 3x out, and I'll be left with 2x minus 5. Okay. Same thing here. Is there any number that will divide evenly into both of these? And the answer is 4. 4 divides into 8, and 4 divides into 20. Notice both terms don't have an x, so I can't factor an x out of this, so I can just factor 4 out. Now when I take 4 out of 8, 4 times 2 makes 8, so I leave a 2 here. And 4 times 5 makes 20, so I leave a 5 there. And this is what we have. So we factor out the GCF out of both groups, 3x and 4, and this is what we have. Now what are you supposed to notice? I have identical parts in the front and the back. The front half and the back half, 2x minus 5. That will be one of our factors. If you remove those factors, what are you left with? 3x plus 4. That's our other factor. So taking away the 2x minus 5 out front, and what are you left with? 3x plus 4. So these are the two factors that will give us 6s squared minus 7x minus 20. So the AC methods, we went a little bit quicker that time. This problem would take forever guessing and checking. There's so many possibilities that I think it saves a good bit of time and gives you a systematic way. Now, one last note, you can or you should check to see if you're correct. How do I check? Just multiply these two polynomials back out, and it should give you this back. If it does not, then you've made a mistake. If it does, then yay, this is your answer. We've factored it. Okay? So this just takes practice. I would suggest practicing some problems that you know the answer to. Doing this a few times, and you should hit kind of a groove and feel good. And you may go a few days without doing it and then forget and may want to practice again. But once you build up a lot of skill with factoring, that'll help you a lot in the rest of this Math 111 course. So good luck with that, and I hope this was a little bit helpful.